In the brain starter, you just have to find the area of these 4 purple bars below. So, do that. Good first step would be figuring out the length and width of all these. So, these are all 2 in terms of the width. Now to figure out the height, we'll just look at how high it goes. So that's 1, that goes up 2, that goes up about 3.5, and then this one goes up 6. So the area is 12, 7, 4, and 2. And then all you have to do is add that together. So we get 2 and 4 is 6, plus 7 is 13, plus 12 is 25 units squared. The brain starter is an example of what's called a Riemann sum, named after this guy. Basically, the idea is you can approximate the area underneath a curve by using a bunch of rectangles. So in a left sum, the left edge of each of these boxes, the left corner is the one that hits it. So the box goes up on the left, boom, hits it, you go straight over, straight down. In the midpoint sum, you can see that the curve goes through the middle of each of these rectangles. And for the right sum, predictably, it hits on the top right corner of all these boxes. Now, there's some advantages and disadvantages to this, of course. To get the true area underneath this curve, these rectangles are missing this part right here, and this, and this, and this. And over here, it's missing these, but also adding these. And the right sum, that's just too big because it's adding these little portions here on the edge. Now, obviously it's not a perfect method to get the area underneath a curve, but it's a good way to get an approximation, especially if your rectangles get narrower and narrower. Then you'll minimize the parts that you're missing here. So for this problem here, we're asked to use 4 rectangles. We're going to use the left endpoints touching the curve on this function, negative x squared plus 6x minus 4, between x's of 2 and 4. So the first thing I'm going to do is draw in these rectangles. And since there's 4 of them between 2 and 4, obviously we'll have to make it 2, 2.5, 3, 3.5 to get it all the way. Look, I've drawn them to the best of my ability. So now we know that each of these, the width of these is 0.5 because it goes from 2 to 2.5 to 3, etc. Now the real key is figuring out the height here. So how tall is this? Well, one easy way to think about this is to figure out, let's look at this first corner here. If we figure out what the height of this height is just going to be the function, or y equals, of 2. Basically, we just plug in 2 to this. So, let me figure out what f of 2, 2.5, 3, and 3.5 are. That will give us the height of all these rectangles. So, by plugging in the values 2, 2.5, 3, and 3.5, I found the height of each of these rectangles. The first one goes up to 4, then 4.75, because if you look at it, the left endpoint is 2.5. And then f of 3 was 5, and f of 3.5 was again 4.75. So the last step, all we have to do is multiply these times 0.5 to figure out what the area of each of these rectangles are, and then we can add them up. So, after multiplying by the widths here of 0.5, find that the first rectangle has an area of 2, the second one 2.375, the third one's 2.5, and the fourth one is 2.75. Now the last step is you just add all of these together, and our area here is 9.25, which approximates the area between the curve between x of 2 and x of 4.